In today's lesson, we are going to be solving log equations. And just like when we solved exponential equations, there's going to be two types of problems. So our first type is each term has a log. What that means is simply there are no random whole numbers floating around in the equation that are extra. In other words, everything has a log attached to it. So our first step of the process is to condense the logs on each side of the equation. Now we did condensing a couple of lessons ago, and when we condense, we are talking about using the product or quotient properties. So if you don't remember, those were the properties where if you saw addition, you changed it back to multiplication, or if you saw subtraction, you changed it back to division. Once you have it condensed, we apply this rule. If you see 1 log equals 1 log, okay, not 2 logs, not 3 logs, 1 log equals 1 log, the log parts can cancel. And all it leaves you with is a very easy to solve x equals y equation. And you'll use basic algebra and you'll solve for whatever letter is in your equation. Now, unlike exponential equations, these we are not done when we get an answer. Every single log equation you solve, you must check all of your answers. Because the one thing you need to remember is you can't take the log of a negative number or 0. So when you take that answer that you find and you plug it back in, if it gives you a negative number or 0, your calculator is not going to like it and you're going to have to cross off that answer. So we're going to start with small problems and we'll work up to the more challenging ones. So let's look at our very first example. Log base 4 of x plus 3 equals log base 4 of 8x plus 17. First question is, how many logs do you see on each side of the equation? Well, on this side, I only see 1. And on this side, I only see 1. If you only see 1 on each side, there is no need for step number 1. We're going to go straight to step number 2. And so step number 2 says, because we see 1 log on each side, we're going to cancel them. So I'm going to cancel that log and cancel that log. So what that leaves me with is x plus 3 equals 8x plus 17. So now we have to move some things around. So we want all of our x's together. So I'm going to move this 8x over here. So I'm going to subtract 8x because it was positive. 1x take away 8x leaves me with negative 7x. I still have my plus 3. I still have my equals 17. So now I want all of my whole numbers together. So I'm going to move the 3 over here. So that means I have to subtract to make it cancel. So now I have negative 7x equals positive 14. To finish getting x by itself, I divide by negative 7. Those cancel, and I get x equals, if you take 14 divided by negative 7, you get negative 2. Now we don't put a box around that yet. We're going to check this number in this spot and in that spot. So here, if I was to put a negative 2 right there, negative 2 plus 3, and I'll write this down, negative 2 plus 3 equals what number? Well, it equals a positive 1. That's a positive, which means it works in this log. I'm going to check it here. 8 times negative 2 plus 17. Well, 8 times negative 2 is negative 16, and negative 16 plus 17 is positive 1. Since both spots gave me a positive answer. No, they don't have to match. They just need to come out to be positive. Then this answer works. Now I will have people ask me, do I have to show this part? No, you don't. Okay, you can do it in your head and that is perfectly fine. But if you don't check and you have an answer that you should have crossed off, but instead you put a box around it, I will mark off on a test. So pause the video and try part B on your own. So let's see how you did. This looks just like example 1. So you should have canceled the logs. You should have been left with 2x minus 1 equals x plus 5. You should have moved the x's together. So that's a 1, so subtract 1x. Cancel. 2x, take away 1x is 1x minus 1 equals 5. You should have added 1 to both sides, giving you 1x equals 6. Divide by 1, you get x equals positive 6. So again, you can check just in your head. I'm going to put 6 right here and right here. Well, 2 times 6 is 12, and 12 take away 1 is 11. That's a positive number. This one's good. Over here, 6 plus 5 is 11. Also positive, also good. Put a box around it. So hopefully you're like, oh, okay, so far those are pretty easy. So more solving. So if you look at example 2a, this is a log. Yes, it's natural log, but it's still a log. So I see 1 log here, I see 1 log here, and that's it. So this is just like both parts of example 1. So go ahead and pause the video and try this one on your own. Okay, so let's see how you did. Yes, you should have started by canceling your logs. You were left with 3x plus 2 equals 2x minus 1. Put your x's together. Subtract 2x. 3x, take away 2x, leaves you with 1x. Bring down your plus 2. Bring down your negative 1. Move your whole numbers together. You should have subtracted 2. That leaves you with negative 1x equals negative 1 and negative 2 make negative 3. Divide by negative 1 on both sides. I'm sorry, where did I get negative 1? Whoops, sorry, that's a positive 1. I like to change stuff randomly. Okay, sorry, divide both sides by positive 1, and you get x equals negative 3. Don't put a box around it yet. We're going to put this right here and there. So 3 times negative 3 is negative 9, and negative 9 plus 2 is still negative 7. We don't like negative results. This is a no good answer. So we're going to cross it off. Well, since we crossed it off, and that was the only answer, that means this problem doesn't have an answer. So you would write no solution. So hopefully you have the idea of the basic ones. Cancel the logs, solve, check your answers. So now we're going to look at one of the more complicated ones. So the reason I say this is more complicated is because I see 2 logs and only 1 log on this side. This is a problem. You cannot have 2 logs. This is where step number 1 comes back in the game. You have to condense. In other words, you have to put them together. So look between the logs. What symbol do you see? Well, I see a plus sign. And hopefully you remember that if you see a plus sign between the 2 logs, when you put them together, addition changes to multiplication. So I'm going to have 1 log now. I'm going to take this stuff, x plus 2, and I'm going to multiply it by this stuff, x minus 3. And it still equals log of x plus 29. That's how you condense. Addition changes to multiplication, subtraction changes to division. Now I see 1 log and 1 log. So now you may cancel. That leaves us with x plus 2 times x minus 3 equals x plus 29. Well, unlike every other problem, these parentheses on this side can't be there. So we have to get rid of the parentheses by distributing. So I'm going to start with x times x, and I get x squared. X times negative 3, I get negative 3x. 2 times x, I get positive 2x. And 2 times negative 3, and I get negative 6. And I keep all this stuff over here. Well, I have some like terms to combine. I'm going to combine these two. So x squared, well, negative 3x plus 2x is negative 1x. Minus 6, carry down the x plus 29. So it's been a while since we've seen these. If you see x squared, like I do right here, you must have 0 on the other side. So we need both of these to move over here. Well, this is a positive x, so I'm going to subtract 1x. Subtract 1x, put him underneath his like term. This is a positive 29, so I'm going to subtract 29. Also under his like term. Those cancel. We have x squared, negative 1 and negative 1 make negative 2x. Negative 6 and negative 29 make negative 35. The next thing you need to remember is when we see x squared, the only way we can solve this is by using factoring. Now, I did make it easy in this lesson. We will only be doing easy factoring in this lesson. So, this is easy factoring. And if you don't remember, what that means is we are looking for two numbers that add to give you negative 2 and multiply to give you negative 3. And when we find them, we're going to put them in parentheses with x's. Well, there isn't a whole lot of options. The only numbers that give you negative 35 are 1 and 35 and 5 and 7. And we know because this is a negative, one of these has to be a negative. And because this is a negative, it's the bigger one. Well, which pair gives you negative 2? That would be this one. So we're going to do a positive 5 and a negative 7. Well, now we have to make two baby equations and solve them. So we have x plus 5 equals 0 and x minus 7 equals 0. And I'm running out of space. So here, you're going to add 5 to both sides. So your first possible answer, notice I said possible, is x equals negative 5. Over here, we're going to add 7 to both sides. So my second possible answer is x equals positive 7. Again, possible. Let's check, starting with negative 5. Put it here. We're going to test it here, here, and here. So negative 5 plus 2. Well, that's negative 3. And negative 3 is no good. So I'm finished testing that one. I cross it off. Well, let's check 7. 7 plus 2 is 9. That's a positive. 7 minus 3 is 4. That's a positive. And 7 plus 29 is 36. And that is also a positive. So this, we can put a box around, and that is our only answer. So the only thing that makes these tough is that you have to do that factoring stuff. So far, we've looked at type 1 equations. Now we're going to look at type 2 equations. Now type 2 equations, what makes these different is there are terms without logs. In other words, you're going to have extra whole numbers floating around in your problem. So step number 1, move all of your logs to the left side of the equation and all of your non-logs, in other words, all of your whole numbers, to the right. Then condense the logs on the left. Sometimes that may not apply. Then we're going to do some changing that we've seen before. We're going to change from log form to exponent form and solve. So this is what it's going to look like to start with. We're going to use our circle. B circles over to x, and it circles back to y. So b to the power of x equals y. B to the power of x equals y. When we make this change, the log goes away. Once you're done solving, again, just like type 1, you have to check your answers. So let's take a look at some easy ones and move up to harder ones. So this first one, we want the logs on the left and the whole numbers on the right. Well, this is a log and it's on the left. This is a whole number, it's on the right. Step 1, good to go. Step 2, if there's more than one log, we condense. Well, there's only one log. So step 2, good to go. Step 3, this is our circle. So I'm going to go start here at the 4. 4 circles to 2, and 2 circles back to the parentheses. So it's 4 to the power of 2 equals x plus 3. Notice the log is gone. Okay, when we change from log form to exponent form, the log disappears. Now we have some solving to do. Well, the first thing you want to do, figure out this number. 4 squared, hopefully everybody knows it's 16. Then we simply want to get x by itself. Well, I got to move this 3, so I'm going to subtract 3. 16 take away 3 is 13. Now again, I'm not going to put a box around it yet because I haven't checked it. So I need to check it right there in those parentheses. Well, 13 plus 3 is 16. And that's a positive number. So I'm going to go ahead and put a box around it, and I'm done. So we just did one, so I want you guys to pause the video and try part B on your own. So let's see how you did on this one. So you should have circled just the way we did. 5 to 3, 3 to the parentheses. So you should have written it as 5 to the third power equals x minus 4. This you put in the calculator. 125 equals x minus 4. You should have added 4 to both sides. 129 should have been what you got for x. And if I test it right here, 129 take away 4 is 125. That is definitely positive. That is definitely a good answer. So those were the two easy ones. Hopefully you're thinking, okay, so far so good. So let's take a look at our next kind of examples. So we're actually going to do the harder one together. We're going to do part B together. So if you look at part B, step 1 says we want all of the logs on the left, all of the whole numbers on the right. Well, we don't have that. We have a log equals whole number and another log. This log right here has to go over here. So I'm going to do the opposite, so that means I'm going to add log base 6 of x. No, you may not put these together. You write it as log base 6 of x plus log base 6 of x plus 5. Again, no, you may not put those together. That's step 1. Step 2 is condense. Yes, we need to condense these two logs. So if we look between them, we see a plus sign, and so addition changes to multiplying. So log, 1 log with a base of 6. Yes, the base is important. So we're going to do x times x plus 5 equals 2. So that's condensing. After we condense, step 3 is to circle. So start at the base. 6 circles over to 2, and 2 circles back to all of that mess. So 6 squared equals all that stuff. X times x plus 5. Okay, well, let's do some simplifying. Does everybody know what 6 squared is? Hopefully you know that that's 36. And hopefully you're thinking on this side, let's go ahead and distribute. So x times x is x squared. And x times 5 is positive 5x. Well, you should be thinking at this point, oh no, there's that x squared again. That means I gotta have a 0 and I gotta factor. So I'm gonna subtract 36 from both sides. Notice I put it at the end because there's no like terms. That gives me my 0. I have x squared plus 5x minus 36. So you're thinking, okay, I have to find two numbers that add to give me 5 and multiply to give me negative 36. Well, I have 1 and 36. I have 2 and 18. If I divide by 3, I have 12. If I divide by 4, I have 9. Can't divide by 5. If I divide by 6, I get 6. Multiplying is a negative, so we have 1 positive, 1 negative. But adding is positive, so the bigger one's positive. So I'm going to put a negative with all these small guys. So which pair adds up to 5? Well, that would be that pair right there. So we're going to do 0 equals x minus 4 in parentheses, x plus 9 in parentheses. And again, we need to make two baby equations. 0 equals x minus 4, and 0 equals x plus 9. And again, I'm almost out of space. I need x by itself. Since this is a negative, I'm going to add 4 and add 4. So I get a possible answer of positive 4. Since this is a positive, I'm going to subtract 9 and subtract 9. So I get a possible answer of negative 9. So let's check. We need to check it here and there. So let's start with 4. Well, 4 plus 5 is 9, and 9 is positive. Over here, if I put a 4 there, 4 is positive. We're good. Put a box around 4. Negative 9. Negative 9 plus 5, well, that's negative 4. Negative 4 is bad. Cross that off. The only answer is positive 4. So I would like you to pause your video. The reason I said example or B was harder is because of this first step. Okay, on A, you already have your logs on the left and you already have your whole numbers on the right. So all you have to do is start with step number 2. So start with step 2 and try it on your own. Well, hopefully hopefully you compared this problem to this step right here, because that's where they are similar. So plus sign changes to multiplication. So log 1 base of 2 x times x minus 7 equals 3. Now we're going to circle. 2 circles to 3, which circles back to all the mess. So 2 to the third equals x times x minus 7. 2 to the third is 8. And if we distribute, x times x is x squared. X times negative 7 is negative 7x. Just like the other problem, we need a 0. This is a positive 8, so I'm going to subtract 8 and put it at the end. 0 equals x squared. Whoops, that should be a minus, not a plus. Minus 7x minus 8. You're looking for two numbers that add to give you negative 7 and multiply to give you negative 8. Hopefully, the two numbers you found were negative 8 and positive 1. And so you should have made two baby equations. 0 equals x minus 8 and 0 equals x plus 1. Add 8 to both sides. Your first possible answer is x equals 8. Subtract 1 from both sides. Your second possible answer is x equals negative 1. So now we have to check those two answers. We're going to check it here and here. So let's start with 8. If I put an 8 there, nothing else to do. 8 is positive. We like it. I put an 8 here. 8 minus 7 is 1. 1 is positive. We like it. Put a box around it. Negative 1. If I put negative 1 right there, it can't do anything else, and it's a negative 1, and negative 1 is bad. So we're going to cross that off, and your only answer is x equals 8. So let's look at our last two examples. These are kind of your specialty cases. So the first specialty problem involves something that we've seen before, and that's ln. So if you look, and we start our problem, logs on the left, whole numbers on the right. That's good. How many logs do you see? Well, I only see one log, so there's no condensing to do, so that's also good. The next step is where we're going to make a little change. We need to circle, but the problem is there's no base. So here's what you need to remember from previous lessons. ln is the same thing as log base E. This is one of those super duper must memorize things. So I'm going to, in place of ln, I'm going to put log base E. I'm still going to keep everything else exactly the same. The reason I did that is because now I have a base to start my circle. So my circle is going to start at E, go over to 7, come back to the parentheses. So E to the power of 7 equals 6x plus 5. Well, we have an E button, so if you use your E button, E to the power of 7 is a big, long decimal. Yes, you may round. So it's 1,096. We're going to use 3 decimals like we did last class, 0.633. And that equals still 6x plus 5. Well, now we're just in algebra land. I need x by itself. I'm going to move my 5 first. So I'm going to subtract 5 from both sides. That leaves me with 1,091.633 equals 6x. I'm going to go ahead and divide by 6 to cancel those. And so my answer is 181.939. So let's check that answer. I have one place to check it, and that's right there. So 6 times this giant number is an even bigger number, and it's still positive. Well, if I add 5 to that already big positive number, it gets even more positive. So this does work. So let's look at this last problem. I want all the logs on the left, all the whole numbers on the right. Well, here's a problem. There's extra whole numbers. Okay, this 1 and this 2 are not in parentheses. If they are not in parentheses, they must be moved. So which one do I move first? It's the 1. So this 1, I'm going to subtract 1 from both sides. That leaves me with 2 log x equals, well, 13, take away 1 is 12. I am then going to take this 2, and I need to get rid of it. Here's the big mistake I see students make. Do not subtract. This is multiplication. You must divide. That leaves me with log x equals 6. So I've moved my extra whole numbers. I only see one log, so I don't have to condense. So I'm on to my circle step. Well, hopefully you're thinking we have a problem. This log doesn't have a base. But unlike this one, part A, it does have a base. If you have a log and there is a regular log and there is no base, you need to remember that it's always an imaginary 10. So I'm going to start my circle with 10. 10 to 6 and back to x. So 10 to the power of 6 equals x. If you put this in your calculator, you will get the number 1 million is equal to x. So we have to check it. The only place we can check it is right there. 1 million, right there. Does log like the number 1 million? Absolutely. So this is a positive number. It gets a box around it. And that is the end of our lesson. And we will see you in class.